Hello again. We are going to continue in our discussion of trigonometry, and we're going to talk about how trigonometry can be used in geometric figures, different geometric figures. This is lesson 9.2, so let's get started. Even though we have a shape that isn't a right triangle, we can usually find a right triangle somewhere in that shape. We have isosceles triangles, we have a rhombus, we have rectangles, and we have trapezoids. And you can see that there are right triangles found in those basic shapes, as well as others. Okay, so let's look at an example. It doesn't have a right triangle explicitly drawn in the diagram, but you can see that there is a right triangle somewhere in that picture, and we just need to use our information to figure out which right triangle we're going to use. We have a 25-inch diagonal of a rectangle, and it makes a 32-degree angle with one of its sides. What are the dimensions? So I actually need two answers to do this. Well, let's figure out the length first, I believe. So there's my right triangle. Okay. Oh, I'm actually going to figure out the width first. So if I look at the width, that's going to be the opposite of the 32-degree angle, and the side that I know is 25, and that's the hypotenuse. So I'm going to use the width, which is the opposite, and the hypotenuse of 25, and that means I'm going to use the sine of 32 to figure out the width. Okay, so just like before, if I have fractions, I'm going to cross multiply. So the width is going to be equal to 25 times the sine of 32 degrees, and my calculator says that's about 13.2 inches. Now to figure out the length is on the adjacent side, and I can use the hypotenuse again. So adjacent over hypotenuse, that's cosine. So I'm going to say that the cosine of 32 degrees is equal to the opposite, which is the length, or the adjacent, which is the length, over the hypotenuse, which is 25. And cross multiplying, I get that the length is 25 times the cosine of 32 degrees, and that's 21.2 inches. Now I could have easily used the length and the width and used tangent, and you may not have thought of this, but since I have two sides of the right triangle, I could use the Pythagorean theorem to figure out the other one. So when you're solving these and you have most of the information, you end up with a lot of choices as far as figuring out any additional information. So like I said, I could have used three different ways to figure out the length of that once I already knew the width and the diagonal. All right, here's another example. It looks like I have an isosceles triangle. The legs are 10 centimeters each, and the base at the bottom is 14. So what is the measure of the vertex angle? That's going to be the one at the top. Okay, that's what we call the vertex angle in this triangle. So I cut it into two right triangles. Each one of them is going to be congruent to the other. So that means that theta is going to be at the top. That's actually not going to be the vertex angle, but it's going to be half of it. So once I figure out theta, I can easily figure out the vertex angle by doubling theta. So if I look at where theta is, 7 is the opposite of that angle, and 10 is the hypotenuse. So I'm going to use the sine of theta equaling 7 over 10. Now this is a case where I need an angle, so that means I need to use an inverse function. The inverse of sine is sine inverse. So theta is going to be the inverse sine of 7 over 10, and that's 44.427 degrees. That's theta, which is half as big as the angle that I want. So the vertex angle is going to be twice as big as that, which is 88.8 or 88.8, I think maybe even 88.9, depending on how you round. Okay, here's a more difficult example. We have a trapezoid, and I need to find the value of x. So where are my right triangles? There's one, okay, and I can use that to figure out the height of this trapezoid. Okay, so looking at that triangle, 71 is my angle, h is the opposite, and 12 is the hypotenuse. So I will use the sine of 71 degrees. That's going to be the opposite, h over the hypotenuse, 12. Cross multiply, and I get that the height is 12 times the sine of 71 degrees, and that's about 11.346223. I keep that as accurate as possible in my calculator. I'm going to round it on this diagram here, but when I use that number again, I'm going to use the more exact number that's in my calculator. So I get rid of that triangle, and I look at the triangle that's on the right. So the height is going to stay the same, because it's still the height of the trapezoid. It hasn't changed. So it's about 11.3. But now I'm dealing with this right triangle that is on the right-hand side of the trapezoid. So I have that 52-degree angle there. I have the opposite of it as 11.3, and the hypotenuse is x. Okay, so I'm going to use sine again. Sine of 52 degrees is going to equal the 11.346223, that's the opposite, over x, which is the hypotenuse. Cross multiply and you get x times the sine of 52, that equals 11.346223. And if I divide by the sine of 52 degrees on both sides, then I get that x is 14.4 meters. So that's kind of how you figure out angles and sides in more complicated geometric shapes that aren't just right triangles. You can still do it, you just have to figure out where the right triangles are. If you have any questions, please let me know, and I will see you tomorrow.